Hello guys, welcome to another episode of Xa Talk Show. So Advent of Code 2024, Day 2. Let's begin coding. Okay, let's see, maybe we can do it fast. Video check, video, am I alive? Yes, alive, and audio check. Advent of Code number 2. Wolfram language. Okay, do we have Wolfram language ready? New notepad, shift enter to evaluate it, and this needs to go here and magnify. Okay, and this needs to go here. Okay, so can you see it? Yes. Day 2. Okay, let me try to do this fast. Maybe 20 minutes or 30. There are people who finish it in like 2 minutes. Okay, so the input, here's the input. What is this? Okay, let's start here. Wolfram language. Okay, code. Var. Okay, so that there it is. The usual data consider many reports, one report per line. Each report is a list of numbers called levels that are separated by space. Okay, this example data contains 6 reports, 6 rows, each containing 5 levels. Okay, so rows and the levels. The engineers are trying to figure out which reports are safe. Okay. The red-nosed reactor safety system can only tolerate levels that are either gradually increasing or gradually decreasing, so a report only counts as safe if both of the following are true. The levels are either all increasing or decreasing. Okay. Any 2 adjacent levels differ by at least 1 and at most 3. Okay, so they need to be gradual and okay, and or increasing or decrease. Okay, in this example above, the report can be found 76421. Check safe because 76421 or decreasing and no more than a gap of 3. Okay, yeah. So second 12789. 12789, no, because there's a gap of 4. Okay, 97621, unsafe because 62 is a decrease of 4. Okay, yeah, I get it. Okay, so in this example, 2 reports are safe. Okay, number 1 and the last row. Analyze the usual data from the engineers. How many reports are safe? Oh, easy. Okay, so first of all, you x2, you want to convert it into a matrix. Okay, so string split. Okay, x1. Okay, let's say x input. So evaluate it. Now it becomes okay, so yeah, so it becomes one thing. Then what you want to do is, all these are actually strings. So what you want to do is you want to okay, to expression that converts string to actual numbers. Okay, so to expression add is the prefix notation for the square brackets. So evaluate that, we get the same thing. Then apply another function in front of it, which we partition the list into 2 elements. Okay, so we can do function partition takes 2 arguments. The first argument is the list the second argument is how many rows are there? 1, 2, 3, 6, 5. Okay. Okay, minute. There we have it. 76421, 764. Check. Okay, once you got that, so for each one you want to check if they are ordered. Okay, there it is, ordered queue. Let's look up the documentation. Wolfram language, the most advanced programming language on earth. Okay, it gives true if all the elements are canonical order. Okay, so let's see. So we can do a test, ordered that, if that's true or not. False. Well, that's because they are reverse order. So use the ordering function p to determine. Okay, you can, you can do it twice. So if you run this will be true, right? So you see, so you can, so you can do a or. So let's show. Okay, so or either that or that. Okay, true. You see, so but or has a syntactical shortcut that would be vertical bar. So let me show you. Okay, syntactical shortcut, fantastic. So, but if you use this a lot, then Wolfram language becomes hard to understand. What? Where is my comment? Oh, the Wolfram language comment. There's only one comment, block comment like that. Okay, so if you run this or failed because yeah. Okay, so you need actually because of the space, you need to have the operator there. So or we'll do it. Check the row is ordered. Okay. So now you just want to know what you want to know. Okay, you want to know the order, but the other thing you want to know is if the differences in the list is no more than 3. So if it's 3, does it work? Let's see at most 3. So when the difference is 3, it's still okay. Okay, so let's see if there's a function that compute the differences of adjacent numbers. So check documentation. Differences list give the successive difference. That's what we want. Let's see. Run it. Fantastic. And you want the absolute value. Okay. So you want to apply absolute value to each one of them, and you want to make sure they are less than 3, less than 4. Okay, less or equals to 3. Okay, so you apply a function. So absolute value map. Okay, so you map the absolute value to this thing, to the differences. Actually, let's put the output here so we kind of have some idea. Okay, here's a whole code, very simple. Okay, now we're gonna apply the absolute value to all of them. So you got all positive. That's right. Then you just make sure all of them are less or equals to 3. So yeah, so so you can map you want to make sure all of them are less or equals to 3. So you can do less than 4 because we know they are all integers implicitly. So you can map there are other ways. So let's see. Yeah, you want to make sure all of them is okay. Anyway, let's just do the dumb way because I got tired of the advent of code. Fuck, because they don't care about efficiency. They don't care about like, in other words, if you spend real time, if you are a master of computer science, you create the greatest code. It doesn't matter because because all it cares is the answer. Lots of issues. So let's just do the brainless way, okay? So apply a function and to each one of them, and you want to make sure is less than, I believe, less than x. Okay, so x less than what number? Less than 4. Okay, it'll give you a bunch of true and false. No, wrong. Wait. Yeah. Okay. So the list it should be here. Okay. Okay. So let's. What is this? Less than code with 2 args. 1 argument is expected. Oh yeah, that's right. What? What? Look at less than. Less than takes 1 argument. Operator form that yields. Oh, okay. So operator form yields x less than y. Okay, so this is new. 2015. 2015 is a year I was not keeping up to date with Wolfram language, so they added this new function. So less than takes just 1 argument. In that case, you don't need to define your function. You just say less than. You see, fantastic. And all you have to do is just apply the and function to all of them, so that there's a shortcut. Wait a minute. Okay, wait. So so when this pass, that means this row pass. Okay, so now you just need to apply this to every row. Okay, so let's, I guess, clean up the clean up the code. Let's start a new one. So let's start a new one. So let's just make them like one shot. Remove the intermediate. So this is or so what? So you need map to the x2, and you map a function to it. And what does this function do? The function, first of all, needs to apply ordered. Okay, the function first of all needs to apply. Let's make it functional. I mean, let's not use a shortcut. Okay, so and this is just x, so simple. So if one of them is ordered, that means it's increasing or decreasing, it pass. So then you need an AND. Okay, so AND, so first of all, they must be increasing or decreasing. The other thing you need to do is to check, so ordered, we don't care. You need to check the difference and this line. Okay, so that. So basically what this does is you find the differences, the absolute value of it, and all of them, each one of them is less than 4. You map to it. Then you just say you got a bunch of true and false. Then you apply AND. You apply AND to all of them. So if either one of these conditions is true, both of them must be true, then you got it. Okay, so that is the function. So the expression we don't need, so that is a function mapped to the list, and you don't need that. Okay, wait, so what do you get? Then you got a bunch of true and false, I think. Yeah, so true, false, 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 true, true. Okay, in this example, only how many are true? 1, 2. So I got it wrong. So the difference, so they are not just less than 4, but also not 0. So it should be, wait, let me see, less than 4 and not 0, 0. Okay, yeah, okay, not 0. So not less than 4, and actually you need a function. Okay, yeah, let's do a function. So function, and this expression will be, let's just say 4 less or equal 4, actually x here, and greater than 0. Okay, now that's clear. Run it. True, false. What? True. Fuck. This got another one wrong. What? What is this? So let's see. Wolfram language. Shift enter. Okay, so let's say if this is 3, shift enter true. If this is 0, shift enter false. Fuck, why is it true, false, true, true, false, true, true, false, true? So what's wrong with this 97621? So that's decreasing. Oh, not, it's not less. Okay, it's less than equals to 3. Okay, run it again. There it is, seems right. And then all we have to do is apply AND across. Okay, so apply AND across like before. By the way, this add sign, that means, so when that's a syntactical shortcut. When you have f two symbols, f add then another symbol, that means this. Okay, that means yeah, that means this exactly. Okay, just syntactical shortcut. You know, I can show you. Yeah, full form, bracket, paste, shift enter. well, yeah, where does the x come from? This is wrong. This x needs to be, yeah, so it needs to be list A, B, C, okay? Shift enter, there it is. Well, actually, so what let me show you again, okay? Actually, what you need to do is you need to, let's do it here. So I'm trying to show you how this syntax is equivalent to that. So what you do is you form and hold. Hold is important because otherwise that expression gets evaluated. So what you want to do is this. Okay, so you see, apply fx. So that apply is similar to functional languages apply, like in Emac Lisp. It just turns the list items, feed them into the function. Okay. Now in Wolfram language, because it's symbolic term rewriting system. So anyway, so let's remove that. Let's put it here. So let's like extra. Okay, back to the code. Close that. Back to the code. Okay, so run it. Wait. So you don't want to end. You want to count. So okay, yeah. So count. You want to count how many are true. So okay, so let's write a function. Then use the built-in function count x, and you want to count how many items are true. So this is a function. So now a function. Now you just apply the prefix notation apply to this thing. Okay. So run it. Two rows pass. So is that what we want? Yes. Okay. So that is the solution, and okay, that's fantastic. It's yeah. Okay. So that is the solution, and make a backup. And what we want is the do our okay. So let's make a copy of this and do it new. Okay, now let's do the get our puzzle input. Okay, a big one. We don't care, we just like brute force it. 342. I don't even have time to drink my coffee. Let's see, 342, are you sure? Yes, shut the fuck up. Paste, submit. That is not the right answer. Fuck. Okay. Why is it not right? Oh, that's right. Because, you see, this tricky fuck. You see, not all numbers are the same number of items. You see, yeah. Okay, so that means, yeah. Okay, so we need to okay, so we need to get the number of items per. You see, it's tricky. The input, the toy example doesn't show because I assumed, I just plug in a number, but it's trying to be tricky. So you okay, instead of okay, so let me just work on that. So instead of string split, this time you just split on the end of line character, then you map string split again. Okay, so function okay, so you map it to here. Of course, you map to this thing. and this time you split by white spaces, okay? By default it's split by white space, okay? So actually you don't need the function, you just say that, okay? So that gives you yeah, so each row is different length. Then you just need to say two expression there, and you don't need partition, okay? Don't partition it, okay? So I think that's that. So remove that. Now comment is out. Okay, so let's try it. No, well, that's because you need to put this here because XOR Emacs Wolfram mod. Okay, there we have it. Now let's try to reduce some of the length. Okay, run it. And there it is, 135. Okay, so now we just remove this whole input and use this input. Okay, and put this back. Okay, run it. 606. Are you sure? Yes. Yes, please. So how do I resubmit? Make sure something return to day 2. Okay, paste 606. That is the right answer, of course. Continue to part 2 celebration. Hello, Huang. Pomelo. Okay, I don't know what is pomelo, I forgot. So how many minutes? 30 minutes. Okay, so the result is 606. Okay, so that is our code for day 1. Put it back, and now let's do day 2. Okay, I mean part 2. Part 2. Syntax correct, showing browser. There is our code. Oh God, I hate this. So yeah, part 2. Okay. Okay, what is the part 2? Let's see. What? Part 2. Okay. Part 2. The engineers are surprised by the low numbers. The problem dampener is a reactor something tolerate a single bad level. Okay, tolerate a single bad level. Okay, same rule apply as before, except if removing a single level from an unsafe report would make it safe, the report instead count as safe. Okay, the nature of the problem changed somewhat significantly. So let's see. So 13245 is now safe because you remove, oh God, this problem is becoming complex. So you remove 3, it works. Oh shit. So if you can remove one number in a row, then it works. Well, you can do trial and error. What does it take? There's 1,000 numbers. I don't want to code this. So you see, there are two conditions. One condition is that they must all increase monotonically or decrease monotonically. So that's one condition. So if you have a bad number there, let's say you have 1, 2, 3, 100, then 4, 5, 6. Okay, so that 100 is a bad seed. You just kick it out, then it's increasing order again. So one of the issue is that the order. So if you can remove one element, then it counts, okay? But the other condition is that the difference must be, oh God. In fact, these two can be combined. Yeah, not necessarily. Okay, so so I'm gonna show. Okay, so anyway, so you can remove one number, so that's one thing, order. So okay, the other thing is that the difference. So if you remove one number and if you remove that specific item, and if that fix the differences problem, or the differences are less than 3 or equal to 3, then it also counts. You see, you cannot apply these two conditions separately because whenever you remove one item, it must be that item. It then satisfy both. Okay, so what you can do is that you can just do brute force. So just go through these numbers. For each row that fail, then you try to take out one row, one element, and try it again. Actually, that would work. There's only 1,000 items. Let's see. Yeah, for each row, the maximum number of tries is like 10. Yeah, brute force works. Let me give it a thought about if there's some trick. You remove one item. So if removing one item works, fuck. Let's just do it, okay? So if we can go to the Wolfram language and paste it there so you can see the code. Now it's clear. Oh, we got a nested function screw up. That's why it's red. I mean, not necessarily screw up. That just means the syntax is potential problem because you are using X in it still works because function has a tighter scope, but better if you just change it to Y. Okay, let's change it. X to YY. Okay, so copy that, paste there. That's beautiful. And copy that, paste here. So now it's like looks beautiful. Okay. Okay, but you gotta solve the problem. By the way, there's a lot of shortcut notations, so you don't have to have all these nested brackets. Okay, so yeah, so this. So this and this whole and this and that. Oh God. If you can remove just one item, what does it signify? You know, if you can just remove one item. Hey, Luis from Germany. Okay, so these problems. Okay, so what am I doing? Do I want to do this? Yes. Okay, I guess I have to. I have no choice. Because, okay, let's call this. So if you can remove one item, is there some trick? So order, first of all, you gotta know it's increasing or decreasing. Given a bunch of numbers, they can potentially be chaotic. So there's no you cannot say which it tends to be increasing or decreasing. It could be chaotic, up and down, up and down. So that means there's no shortcut to say this is decreasing or increasing. Okay, so you got a bunch of up and down. So their difference is gonna be some positive and some negative. So if it's all positive, so actually you don't actually need this ordered function. You can just check. You just take the difference here, and if it's all positive, but also you also have to make sure they are not zero. So if it's all positive and doesn't contain any zero, then it's increasing or decreasing. Okay, then so all positive, it's increasing, but you also have to check whether it's all negative. Okay, and no zero. So first of all, check the item has no zero, then check it's all positive or negative. Okay, so that's one thing. Maybe I should write out. Check the diff list has no zero. Then check if it's all positive or all negative. If so, the row is good. Okay, so that's the mechanism underneath this. So but now it asks to remove one item. So can we look at the mechanism to see. So that means if it's all if there's no zero, okay, I think it'll work out. So there is, okay, so thinking is like 100 times faster than talking. So in my mind, I kind of already know what to do, but to express it in speech will take 30 seconds. So basically, you check if this condition met, it's good, but if this condition doesn't work, then you check if there's only one zero. Okay, if there's only one zero, then then you can check the second condition. If it works, then that's fine. But otherwise, if the same position that is the zero is causing one of the negative number or one of the positive number, then it also work because you presume you remove that item. Okay, so how do we express this succinctly? Because Uganda, wow, in Uganda, Uganda. Where is Uganda? That's in Africa, right? Wow. So okay, so remove one item. This pesky problem. You just remove one item. You know, actually the easiest is just brute force it, you know, because at the end of a code they don't really care about code efficiency. You know, there's nothing you can show how, you know, it only care for the answer. So if you can do it, you know, like run the code in 2 minutes, then that's fine. So the easiest way is actually just brute force. Then you don't have to think about the problem and then recode the problem. You don't have to. So you just brute force, okay? Yeah, let's just brute force. First check if the row pass. If not, then you want to try remove each item. So write a function ff that checks if the row pass. Okay, now run ff on a row. If no pass, then you want to try to remove one item of the row, and you know, remove first item, remove the second item. So you got a list of you know, so suppose that there are 3 items in a row, then you got a total of how many possibilities? 1, 2, 3. Yeah. Map ff on a list of rows, each one is with one item removed. Okay, if any of this is pass, then it is pass. Okay, that is the algorithm. So how do you generate this list of rows? Okay, we can try it. And you know, let's say 1, 2, 3, 4. You want generate, so if the rows, if the list has 4 items, then you got 4 possible. So you got 2, 3, 4, or 1, 3, 4, or 1, 2, 3. Okay, so you got wait 1, 2, 3, 4. 2, 3, 4, 1, 3, 4, 1, 2, 4, then 2, 3, 4. I mean, then 2, 3, then 1, 2, 3. Okay, so the possible number of rows is the same as the length of the list. Okay, but the question is, how do you generate this list without, you know, brute force? We can do it in a simpler way. We can just do a permutation and remove. Yeah, let me show you. Okay, so permute that returns all possible rearrangement of the elements. No, not, you know, so we want a permutation list. permutation matrix represent the permutation matrix given by permutation vector perm a structure array something maybe. What does this return? Okay, that's missing argument. Permutation matrix. Yeah, fuck, that's not what we want. You always got this kind of problem. Okay. That's not what you want. Yeah. It kind of, no, that's not what you want. So there's a function, okay, so permutation least obvious, why didn't you think of that? Yeah. Run the line. What? Returns a permutation list representation of permutation perm. No. No. You want permutation cycles? Yeah. Now we just want the list of permutations. What is the related guide? Permutation cycles, cyclic permutation representation. Permutation is a fascinating subject of discrete mathematics. Okay, if you guys have not studied it, and it's fascinating and easy to understand. And it's also represents group theory. So if you guys have not studied permutation, you can start by going to Wikipedia, permutation. Okay, just read the article. Then you'll find related links to so much others. Okay, so permutation, you see in Wolfram language you got like 20 functions on permutation. So it relates to group theory and combinatorics, probability. Well, for example, lottery. Lottery. What are your chances of winning things? Factorial. Factorial. So and group theory and matrices. Okay, so let's go back to the problem. There it is. All permutations of arguments of the expression. That's what we want. Yeah. Permutations. Run it. There it is. Okay, that's not, that's actual permutation. Actually, I think we are digressing into different things. Because to do this, to generate this list, we can just manually try to map and but permutation is much simpler way. 1, 2, 3, 4. Yeah, because it what? Permutation is not what we want. Tuples, okay? I think what we need is tuples. All possible tuples. Let's see. Tuples n generates a list of all possible n tuples of element from the list. That's what we want. So tuples that and just 3, okay? Run it. Oh, okay. So, but then it, no, well, that's not what we want. Shit. Okay, but I'm pretty sure. there is a single command that returns subsets. That's what we want, subsets. Okay, check subset 3. Yeah, let's see, right? No, that's okay. So you need the extra argument to specify. Yeah, so you want exactly 3 elements. Okay, run it. Perfect. That's what we want. 1 2 3 1 2 4 1 3 4 2 3 4. Okay, now I have to memorize this because this this permutation tuples subset comes up often, especially in these kind of TOEIC problems. So now I remember, you just remember what they are. So you see, this is why Wolfram language is like very high level. In Python, in almost all languages, you have to code yourself. Most of these functions are in Wolfram language since 1989. So, so over the past 30 years, gradually, like very gradually, Python, for example, they added some of these in library. For example, in Python, I believe you have I'm pretty sure you have permutations. I don't know about tuples or subset, but you have some of these, like after 20, 30 years, they started to add it. But many others, you just have to code it yourself. And lots of TOEIC problems, like in programming industry, for beginners or the nerds, like the Unix fuckheads, the Bash, the Unix fuckheads, or the Python or the Lisp, they will often compete. Like, how can you? This is the most, especially the scheme Lispers. They'll do this like every year, all the time for 30, 40 years. Like you'll see like what's the most elegant way, recursive tail recursion doing like they just repeatedly code these functions over and over again. Which I did, I did in 1990s using Wolfram language. By that at that time you don't have tuples, okay? You don't have you don't have these, except some of these are in the library. Okay, so tuples is added in 2004. Okay, so yeah, okay, so tuples and subset, when is subset added? Subset 2004. Yeah, okay, so they added this whole bunch. So anyway, what is our problem? So subset is what we want, but let's make sure. What if you got 2 true? Do you still get the right answer? Yeah, I think so. Yep, that's what you want, subset. So the length is gonna be, 1 less than the length. So that's how you generate all the other possible. Okay, so okay, I'm digressing so much. I need to work on the problem. So brute force. So this generates all possible. Then you just apply your function to it. Okay, let's do it. So this is a function, no? Okay, so you need write the function. Check row, okay? Check row will be this function. Okay, so let's change that to XX. That's the body of the function. Okay. That is a function, check row. Okay, so let's actually, it returns, what does it return? Return true or false. And we can try it on, let's say, check row. What is a row? Yeah. You know that. So let's put it here. Run it. No. Okay, so got something wrong. Oh wait, so this is actually this is not yeah, so I know what's going on. So we are actually working on the whole expression. So check row actually should just be yeah, so not the count. Okay, so we don't need the count. Yeah. Okay, so let's try it. There's still something wrong. Reverse. God. Wait, okay, so yeah. This XX is wrong. We got the argument wrong. What? What the? Okay, this stream is becoming no good. Sir, your internet is very slow. My monitor has a slow frame rate. Maybe that is because no, it say okay. Fuck. Control Shift Escape. Let's see. Maybe it's because I'm also recording to disk. But the disk says 0 activity, so something is wrong. Very annoying. something odd because the disk says 0 activity. But I'm recording to disk, so does that mean my disk is filled? No, I should have plenty of space, but yeah, very annoyed right now. I don't know. Internet speed slow. Why is that? Am I doing good? Let me know. How is it? So let's just push on the coding, okay? It's annoying. So map to x2. something. Let me stop for a moment. Let's see. Okay, am I back? Is all good? Seems so. Okay, need to fix this. What the fuck is going on? Fixed. Okay, sounds good. Fantastic. Thank you. Thank you, Hamza. Now we need to fix the problem. Oh, okay. So list. Okay, so list, and then differences at x. Yeah. Okay. So I think this is that. Okay. So. Okay, so that and that function and that difference of at least absolute. Okay, then okay, and I think that's it. This is a function. Okay, then it. Yeah, that's the function that tells me if a row checks out. Let's rewrite it. I mean, let's write it so it's easier to understand. Too many of the map thing. Okay, so and this all let's just use the shortcut. Now it's much simpler. Okay, minute. Fantastic. So now, thank you, Jewel. So we wrote this with the shortcut notation. It's much easier to understand, and in fact, this can be further simplified. Let's do it. Okay, that's just that. And okay, now it's even simpler. Test it, run it. True. Okay. 82, 76, 73, 70, 67, 60. So let's say that it'll be false. Yep. So the function works. So according to our algorithm, brute force way, write a function ff that checks if the row pass, then map ff on a list of rows. Each one is one item removed, okay, which we can do subset. So let's start to use subset. So subset, you want to apply it to the input, actually x2, okay, x2 is our new input. So actually you want to map, okay, so you map the subset this is the input of subset function to this x2, okay, that generates a list of lists, yeah. So okay, so what you want to do, if I'm just gonna code, okay, so if that, then it's true, okay, otherwise you're gonna do this on the subset thing. You want to apply that at you apply that and say end. Okay, something like that. I'm just trying to finish the problem, okay? So I think that's it. So if check row, if it's true, then return true. Okay, so otherwise you find all possible subset. Okay, so here this needs to be, yeah, the subset, that's the argument, okay, the row. so you find all the subset, okay, and the length of -1. Okay, so here you will be the length at that -1. Okay, so you could generate all the subsets, then you map the row check row function to each one of them. Then if any one of them is true, then it's true. Okay, so the whole thing can be reduced to OR operation. Okay, so let's rewrite the whole thing to one single OR operation. So it's that or this. Okay, so I think that's the entire solution. So wait, so what does this return? So this returns if that row is true, with the possibility of removing one item. Okay, but this is not a function, so we need to, okay, so let's write the function. Okay, this function we are named check row maybe remove one item. Okay, return true or false. Some documentation always helps, so that's the function name. Okay, and the function will be, yeah, it will be just that. And yeah. This is the function. Okay, okay, so yeah, let's just do it this way. Okay, okay, so then you just map this to you just map this function to x2. Then you got a bunch of true and false. Then you just count. Okay, count this thing. You want to count the number of true items. Okay, I think that's it. Okay, so the whole thing looks like that. Now let's try the toy input. So the toy input, now, God, the toy input is here. Let's try that. So what? So now is good. It was excellent. Now it's good. Okay, let's see. So what is the, thanks to the problem damper, 4 reports are actually saved. So the result should be 4 on the toy input. Okay, so we don't need this anymore. Yeah, that's a cumbersome version. So we are doing, this is analysis. Okay, so this is analysis, and then this is a brute force way, which we are doing. And okay, let's run it. Please make it work. 4, fantastic, beautiful. Now we just try the full input. Put the full input here. Okay. Now run it. Maybe it'll take a minute. Wait, 644. Is that right? What was the answer before? 606. Now 644. Brute force way. Fantastic. Okay. Submit. That's the right answer. Fantastic, guys. We finished. Fantastic. Okay, thank you guys for watching. Bye, guys. Yeah. Okay, copy that, paste it here. Now we can do some cleanup, but that's it. Okay, so put it back, color it, show in browser. That's it.